You may have your quiz maybe as early as the weekend, and the problem set will also be sent to you the earliest by the end of the week. Okay, so the quiz will be in Google form. So it's the quiz are multiple choice. The problem set is a combination of essay and problem solving. So I'll try to make it as easy or as close to the one that we have in the module. So to tell you frankly, I have not go into the details in the module, but I scan over the thing. So I'm going to give maybe some lecture on the way I do it. Padaanin lang natin yung wang-wang. Palagi yan noong COVID dito. Nakaka-stress. Okay? So, I'm going to go over the topic that is related. Kasi, as I've told you, give me 2 weeks to organize everything. Okay? Kasi medyo iba ito doon sa tinuturo ko dito. But as much as possible, I told you, I'm usually post when I see that my signal is stable. Medyo mahina yung signal namin dito. Okay? So, the way I do it is, this is, I think, a win-win situation for you if you keep the materials. And then, whatever lectures that we're going to have here, make sure you have access to that. Hindi ka naman tatanggalin yun sa YouTube to prepare you for your what we call board exam, right? Because what will happen here is you might take even the quiz as open notes. Okay, we're just going to what we call give you time pressure. Because I can assure you that the questions that I have is not really word for word from the one that that we have here in the module. You have to understand the module to answer the question. So, kahit sabihin kong medyo lakasin ko na loob ko na pwede mag-open notes, but it doesn't mean that you're not going to study, because all I can say is you can cheat yourself. I mean, if you want to cheat to get a good grades here, remember when you take the exam, the board exam, you cannot do that. So you might as well prepare how you take the board exam with the way you take the exams that we have here. Okay? So parang inaano mo lang din yung sarili mo. So without further ado, para makaano tayo doon sa materials kung sakaling meron kayong question. So pupunta tayo doon sa topic na method validation. Because I think the material that we have here is something to do with the topic that I usually discuss in method validation. So if we're going to look at the method validation, this is just the process of proving that an analytical method is acceptable for its intended purposes. So inaano ko lang dito kung ano yung mga term na na-meet ninyo. Okay? Doon sa module. The wordings may be different, but they should agree with one another. Okay? So we have this so-called 3R. So meron tayong repeatability and reproducibility. So when we're talking about repeatability, so this is just the spread of the measurement. So the way that you're going to do it is you're going to do the same method, okay, with the same sample and see how the measurements would look like. And usually it's only one lab that is doing it. Okay, you establish through the standard deviation and or the relative standard deviation. So you just try to what we call redo or to see how your measurements are in this so-called repeatability. Okay? So, yung parang inuulit mo lang ng inuulit yung ginagawa mo doon sa repeatability. Okay? Now, ruggedness, on the other hand, this is an assessment of precision or variation by different analysts using different instrument on different days but within the same laboratory. Okay? So, ina-assess mo yung precision nung analysis mo just to what we could look at the variation. So you also use the you also perform it using different people, okay, for different observer or analyst. Pwede ka rin gumamit ng iba't ibang instrument on different days but within the laboratory. Okay? And then you can also have this so-called reproducibility. So refers to the variations obtained by different analysis using different instrument in different laboratories using the same analytical method with similar samples. So anong pagkakaiba nito? What's the difference of this with this one? Anyone? What is the difference of repeatability versus reproducibility? Anyone wants to try? So when we're talking about repeatability, you just measures the variation in measurements taken by a single instrument or person. Okay, under the same conditions. Yung reproducibility naman, it measures whether an entire study or experiment can be reproduced in its entirety. So yun yung pagkakaiba nung dalawa. I think you have a question about that, about the coin. So how are you going to do repeatability and reproducibility? Okay. So repeatability, paulit-ulit mo lang yung ginagawang measurements by a single instrument or by a single balance and the same person in the same condition. But if you look at reproducibility, you want to look at the entire study or experiment if it can be reproduced. So yun yung main difference nung dalawa. Okay? So we also have selectivity and specificity. Okay? And then ito pang isang S, yung tinatawag nating sensitivity. So lahat sila may TT. Okay? So selectivity, it's the ability of a method to distinguish the response of different analytes from each other. So ibig sabihin nitong selectivity, it's able to establish or distinguish the analyte from other species in the sample. So ina-avoid niya yung tinatawag nating interference. Okay? So if we're talking about selectivity, so the signal that you have there is just for that selected analyte. Okay, ability of a method to distinguish the response of different analyte. So yung method na dinevelop mo, magre-response lang siya doon sa selected na analyte mo. Okay? So selectivity, we could say the method is said to be selective if the signal that it gives is a function of the analyte only. Okay? So whether yung sample mo complex or simple, you'll be able to get the response. Now, specificity, on the other hand, okay, its ability of a method to provide a response to a single analyte only. Okay? So medyo malapit lang yung pagkakaiba, yung pagkaka-define sa kanila. But if we're going to look at it, ano ba talaga yung difference nung dalawa? Okay? So when is one selective and when is one is specific? How are we going to what we call differentiate them? So we could say, if we're going to look at specificity, that's the ability to assess unequivocally the analyte in the presence of components which may be expected to be present. Okay, so specificity tells us about the degree of interferences by other substances also that is present. So ito, pwedeng ito yung other compounds na meron. Okay, while we analyze this is some sort of like specificity, except, teka lang, nawawala. Okay, it is like specificity, except that the identification of all components in a mixture is mandatory. Okay, so selectivity requires identification. So parang ang tinitingnan natin dito, if we want to put some analogy between specificity and selectivity, so imagine meron kang mga susi, okay, you're carrying a bunch of key, and only one key among the bunch can open the lock of your door. And if there's a method that can identify the correct key for the lock, the term that we could use there is specific. In other words, the method is specific for the key among the bunch of other keys. Now, if you have what we call selectivity, it requires the identification of all keys in the bunch and not just one that opens the lock. So I'm not sure if it make it clearer to you about the difference of specificity and selectivity. Okay, so it's important for us to understand that the term specificity is used to tell something about the method's ability responding to one single analyte only. Okay, while selectivity is used when the method is able to which do you think is preferred in analytical chemistry? Sa tingin nyo, alin yung preferred? Yung selectivity o yung specificity? If we're going to go by IUPAC recommendations about the two, it prefers the selectivity. Yun yung parang preferred nila. Okay? And I'm showing you here some sort of a paper to back up the claim by the IUPAC. Selectivity in analytical chemistry. And if you're going to look at the definition that they have here, the correct use of the term selectivity and its clear distinction from the term specificity are discussed. Okay, so it's given here that the definition of the selectivity is given as recommended that the use of this term be promoted and that the use of the term of specificity is what we call discourage. So between the two, mas pinapaboran nila yung selectivity. Okay? If we're going to look at the definitions that they have here, selectivity of a method refers to the extent to which it can determine particular analytes in a complex mixture without interference from other components in the mixture. So yan yung distinguish nung dalawa, specificity and selectivity. And as I told you, between the two, the IUPAC in analytical chemistry, they prefer to use of selectivity. Because specificity kasi sa isa lang eh. Okay? Unlike yung selectivity. And then we also have linearity. It was discussed there in the module, how you do the calibration curve. And then we also have due to the changes in the analyte concentration. Okay? Ano yung sensitivity definition na meron doon sa module? Sensitivity is what? Oops, nawawala.
Ability of an instrument to discriminate small differences in analyte concentration.
Okay? In other words, kapag meron tayong sensitivity, usually, okay, siya yung parang slope natin. So you have two types of sensitivity that we discussed there in the module, the calibration and the analytical. Okay? So it's the ability of an instrument to distinguish or discriminate small differences in analyte concentration. So you have here the slope of the calibration curve and the standard or the precision of the measuring device. So meron tayong calculation. Okay? And then we also have accuracy, the nearness to the truth, how your value is close to the true value. Okay? And the way that they determine accuracy is they do this spiking. Okay? So they spike a certain amount and they try to recover it. So if they recover it 100%, then you can have an accurate methods there. And then you also have the range. So this is the highest and lowest concentration that you analyze, some sort of interval wherein linearity, accuracy, and precisions are all acceptable. So you have the linear range versus the so-called dynamic range. And then you also have this limit of detection. So the smallest quantity of analyte that is significantly different from the blank. What we call equation, but at least it's still the same in principle. And then you have the limit of quantitation, the smallest amount that can be measured with reasonable accuracy. Okay, and then we have the so-called robustness. So measure of the capability of an analytical method to remain unaffected by small but intentional changes to parameters in the method. It's an ability of analytical method to be unaffected by small deliberate. So ano yung usually close doon sa robustness? Meron tayong isang R na minention earlier.
Ruggedness po.
Okay? So, paano magkaiba yung dalawa? The robustness and what we call ruggedness. Ano yung we could say difference nung dalawa? Kasi parang napaka tawag dito, they're so close. Okay? In terms of the definition. So I read some article, they said ruggedness should be used as a parameter evaluating constancy of the results when external factors such as analysis, laboratory, instrument, reagents, and days are varied. Robustness, on the other hand, should be used as a parameter characterizing the stability of the method with respect to variations of the internal factors or parameters of the given method. Okay, so we could say robustness is used for expressing the stability of the method against small variations of the intrinsic method parameters, while ruggedness is for expressing the stability of the method against extraneous influencing factors. So I think that's the one that we could differentiate between the two. Kapag stable siya against extraneous influencing factors, then we could say that's ruggedness. Nawawala yung signal ko eh. So ruggedness is when we have external factors. Robustness is something to do with internal factors. So, clear na ba sa inyo yung difference ng dalawa? Masyado kasi silang close kapag tinignan nyo eh. So that's why I said, well, maybe I'm going to have a lecture on this part kasi tinitingnan ko yung materials eh. Okay. Now these terms that I'm discussing to you, I don't really teach this in my instrumental class. I teach this in my what we call analytical or yung Chem 32 version natin. Hindi nyo ba na-tackle to sa Chem 32? These terms?
Yung iba po.
Huh? But it's fine. It's fine. Okay? Kaya nga meron tayo nito eh. But I just want to clear up the thing between those terms. Okay? Because if you don't understand them, you can always mix one with the other. Akala mo pareho. So we're talking about accuracy, and the thing that they do to determine accuracy is the so-called spiking. So you have here recovery. So this is the fraction of analyte added to a blank matrix before analysis that is actually measured by the method. So an unknown was found to contain 10 micrograms of analyte. Spike sample gave a concentration of 14.6 microgram per liter. So find the percent recovery. So if you're going to look at this percent recovery, that's just equals to the concentration of the spike sample minus the concentration of the unspiked sample over the concentration that was added. So if we're going to solve it here, are we going to solve it? Paano natin isosolve? Kapag meron tayong problem na ganito, recovery, because I think the next slide is already like this one. So what is the concentration of the spike sample that we have here? Can we say that it's this one? It says here, analysis of the spike sample gave concentration of that one. Okay. So what is the unspiked sample? An unknown was found to contain 10 microgram of the analyte. So we could say that's minus 10. And the amount that was added was 5. So this will give you what? So you multiply this with 100, missing yung 100 dito. So what is the percent recovery that you have there? So it's just 4.6 over 5. So give you times 100. So that's give you 92%. So that's how they do this, what we call spiking, and see how much they recover when you spike a known concentration of the analyte, okay, in an unknown. This is wherein they spike cefotaxime in a given sample. So they spike the standard, and when they spike it, you will see that the signal coming from it is so high because of the added standard that was mixed with your sample. Now, how do we get the so-called detection limit? Okay. So usually what you have here in the detection limit, you try to get the signals coming from the blank and the signal that contains what we call sample. So what you will get here are curves that shows the distribution expected for a blank and a sample whose concentration is at the detection limit. Hindi lang ano yan, kung ano yung concentration. You also want the concentration to be as low as possible. Yung parang above detection limit lang ang ginagamit mong concentration dito. Okay? So the concentration of any region is proportional to the number of measurements in that region. So the way that you look at this, only 1% of the measurements for a blank are expected to exceed the detection limit. So kapag nagsiset ka ng detection limit, parang yun yung minimum concentration na makaka-detect yung sample mo nung analyte na hinahanap mo. So the blank, as much as possible, hindi siya madidetect doon sa detection limit. Kung madetect man, it's only 1% of all the measurements. So if you're going to look at this, the detection limit would come on this part. And the way that you look at is, what do you think the small s here? Anyone? Ano yung small s na yan?
Standard deviation.
Is you have this sample that contains concentration just above the detection limit, 50%, okay, of these measurements of a sample containing the analytes should be at the detection limit or below the detection limit. So you could see this is the detection limit, right? So look at the 1% here of the blank. And if you're going to look at the percentage of the sample, at least we could say 50-50 sila, 50% above detection limit and 50% below the detection limit. Okay? And the one that separates your what we call detection limit from the blank is just 3 times the standard deviation. So how are you going to determine the detection limit? So this is the same with what discussed in the module. Pero iba lang yung symbol na ginamit namin dito. Okay, I think it has something to do with the source. I'm using a Harris. I'm a Harris person, but was trained by school when I was there in UP Los Baños. So the one that you have is both from school and the other one, I forgot the name, but the first name I think is Gary. Okay, I think it's one of the handout sources there. Gary Christian. Okay, although the one that they use here is Harvey. Okay, so the way that we look at this, how are you going to determine the detection limit? So the way that you're going to do it is you're going to prepare sample whose concentration is 1 to 5 times the detection limit. And then you have to measure the signal from several replicate samples. If you can do more than 7, the better. And then you're going to compute standard deviation. And then in addition to that, you also have to measure some signal from blanks and then find the mean value. Now, once you have this, what we call thing, meron tayong tinatawag na minimum detectable signal. And the way that we put it in our book here, so this is the minimum detection signal, is just equals to the signal coming from the blank plus 3 times the standard deviation. Iba yung form yan doon sa manual. I think that's in the form of this. And if I'm not mistaken, this is like this, and this is the K, and then they put some sort of the standard deviation, small s of the blank. Right? Nakita nyo yan doon? Tapos tinatanong doon, ano yung K value? But usually, the K value that you have there is 3. Ano yung K value doon? Yung ba yung Kruger? Okay? I'm just trying to see. Yeah, oh no, not Kruger. It's the Kaiser. The Kaiser value. Or Kaiser. Ano ba yan? One page dito, Kaiser. O, Kaiser talaga. Kala ko Kaiser. Lalabo na ako. And then, the way that you look at it, the signal from the sample minus the blank, okay, that is proportional to your sample concentration. Of your sample. And the detection limit that you have there is just the minimum detectable concentration, which is equals to, just wait. Come on. Okay. The detection limit that we have there, which is the minimum detectable concentration, that's 3S over M. What is M? That's the slope, which is your sensitivity. So let's try. It's similar to the problem that you have there. So let's say we have your signals from 7 replicate samples with the concentration 3 times the detection limit. So you have this, and this. And then you have reagent blank that gives value of 1.4, 2.2, 1.7, 0.9, 0.4, 1.5, and 0.70. Now you're given here the slope of the calibration curve for the higher concentrations as this one. So you are asked to find the signal detectionable limit, the minimum detectable concentration. And then you are asked what is the concentration of the analyte in a sample that gave a signal of 7.0 nanoampere. So what do we need to do? So we look at the equation that we have here. So we have this one, right? YDL so that means you need to get the signal coming from the blank and then the standard deviation, YBL. Okay? Do you know how to do that in the calculator wherein you input them and then you can get the average and standard deviation? Do you think you can do that?
Yes
Hinahan
po.
natin.
Yes po.
1.4 plus 2.2 plus 1.7 plus 0.9 plus 0.4. Mali ako. Plus 1.5 plus 0.7. And then you divide 1, 2, 3, 4, 5, 6, 7. What do you get? $1.26. YDL is the average or the average of the blank. Or the way I usually ask my student to do it, you know Excel, right? Nasa na yung Excel ko. So do you see the Excel that I have here? So maybe I can 2, 1.7, 0.9, 0.4, 1.5, and 0.7. And then I just put the average, everything there. And then standard deviation of everything that you have there. Oops. So you will have an average of around 1.26. Okay, so babalik na ako doon sa thing. Because we're trying to get this thing here. So that's 1.26 plus 3. And the S that I have there, the standard deviation, if we're going to look the way here, is 0.62. Is that the right one? Medyo mali ata. Just want to make sure. Tama ba yung input ko? 1.4, 2.2, 1.7, 0.9, 0.4, 1.5, and 0.7. Okay, I'll take that. 62 ba yung ginamit nyo? Hello?
Yes po. Yes po.
So you end up with 3 point. I end up with 3.1. Standard deviation. Oops. Trying to see where I mess up. So it's just a 0.624. I just use 0.62. Okay, so we solved the first one. Now the second one, the signal, this one. So it's just 3s over m. So let's say if this is 0.62, the standard deviation. So how are we going to get the m? Oops, Control C. The m is already what? Do we need to calculate for m?
Given na po.
It's already given. So that would be 3 times 0.62 divided by 0.229. So I have here around 8.12. And you are now asked what's the concentration. So this is, we could say 7, right? Minus 1.26. So we have the sample. We divide it with the m, which is 0.229. So 7 minus 1.26 over 0.229. And that is equals to what? Anyone?
25.07.
Anyone?
25.07.
8 point? Oh, is it 8 point? Ika, mali.
25.07.
7 minus 1.26 divided by 0.229. So it's 25. What could be the unit that we have here? NA, so that is that one. So pagpagawa ko kayo ng ganito uli, kaya nyo na? Let's say I give a problem like this in problem set. Yes, Kristen.
Sir, clarification lang po sa standard deviation. Yung ginagamit po natin palagi ay sample standard deviation or population standard deviation.
Usually what we have is sample. Okay, standard deviation here. Kasi yung sample mo, usually, dito, population is if you have a large subsets or a large number of samples. Pero dito naman na meron tayo, ano lang yung ilan to? 1, 2, 3, 4, 5, 6, 7. So we follow the typical standard deviation formula?
Thank you po.
Okay? Ano yung typical standard deviation formula? You still remember the standard deviation formula? Yung square root of the summation of the average minus the given data squared divided by n. Okay. So question, if I gave the same stuff of this in the problem set, kaya nyo? And I would say this is, if we're going to look at this in terms of signals, ito yung ano niya, output niya. So the slope, you get it with signal over the concentration, the y, the change of y over the change of x. Doon, so parang hindi kasi ako comfy yung way na tinuro doon. So that's why I said, oh, maybe I can give you medyo unstable lang. Tumitigil ako pag nalabas yung warning. So the way I do the standard addition is the way it's being presented here. Okay, known quantity, when you have a standard addition, ang ginagawa kasi dito, it's useful when the concentration of your analyte is so low and subject to the so-called matrix effect. So when we have this matrix effect, ito yung merong ibang reagent na usually, or ibang chemicals that are usually higher in concentration than your target analyte. So the matrix effect can enhance or suppress the signal. Okay, it changes the analytical signals caused by anything in the samples other than the analyte. So to solve this problem, they do standard addition. You add known concentration of your standards. Okay, so known quantities are added to the unknown. And the way that we look at this one is here, using this formula. So if you're going to look at this formula, this is the concentration of your sample, okay? And this is the standard that you added. And when you add the added standard, so the concentration of your unknown also changes. And this is the signal coming from just your sample. And this is the signal that comes from your sample added with standard. Okay, so since open notes naman kayo, you don't need to memorize this formula. But let's look how it works with a problem. So you have here a serum containing sodium ion. It gave the signal of 4.27 millivolts in an atomic emission analysis. And then you add 5 ml of 2.08 NaCl. Added to 95 ml of the serum. So this spike serum gave a signal of 7.98. And then you are asked, what's the original concentration of your sodium ion in the serum? So paano natin ilalagay ito doon sa equation na X initial over standard final plus X final, and then the signal of your X and the signal of your S plus X. So, ano yung pwede natin i-assign? Anyone? So anong IX? Anong value ng IX?
4.27.
4.27. Oops, I hate this. And then, now, paano natin i-represent dito? Ano yung hindi natin alam? We're looking for our initial xi, right? Now, how are we going to represent xf? So xf is just xi times gaano kadami ng xi yung hinalo doon. So if you have 5 ml of the standard, so you have 95 ml over 100. Is this clear to you where I got this? So this is what, 0.95x? Can I put it here? And how would I represent SF? So I have the concentration of the S initial, right? And then I just use 5 and dilute it to 100 ml. So what's the concentration of the initial one? Is it this one, right? 2.08 times 5 over 100. So that will give me what? Pag ano, paki-type na lang, if ever. Oops, wala na naman. Okay, so 0.104. So I'm going to use this 0.104 here, right? So, ang kukunin nyo lang dito ay yung value nito. Can I go right away what xi is? So paano yung ano natin? Cross multiplication, I have 7.98 xi. And then on the other side, 4.27 times 0.104 plus 0.95 xi. But can we just go with what xi is? Magsa-shortcut na tayo. So xi is 0.113. Is this helpful? Nakakatulong ba?
Yes po.
Yes.
Pero I don't know, but if you do the thing there in the module, ganun din yung ano niya. Yes, Hana.
Sir, sa pag-express po ba ng final answer, lagi pong like susundin po yung rules on sig figs, hindi po yung whole amount ang ilalagay.
Ben, yun yung gawin mong final significant figures. So here the given are both what? 3 significant figures, all of them, right? So the final answer should have at least 3 significant figures also. Yun yung rule ko sa mga student ko. Tingnan nila yung given. So yung kapag nag-operation man, yung least number of significant figures. They just have to identify the so-called exact numbers, yung mga conversion factors or di kaya number of trials. So they have infinite number of significant figures.
Thank
We
you
will
po,
follow
sir.
significant figures since this is analytical. Naintindihan ba, folks?
Yes, sir.
Kaya sabi ko, ito na lang kaya ibigay ko kaysa i-discuss yung pati ako nalilito eh. Now, the last one that I have here is the so-called internal standard. Okay, so if we're going to compare the so-called matrix effect, so ito yung nangyayari dito eh. So let's say kapag ang matrix mo is reagent water only, konti lang yung compounds na meron sila or chemicals that can suppress the signal of your target analyte, maganda yung ano mo, calibration curve. But if you have, let's say, a groundwater, there's other chemicals there that might suppress the given signal. And if you're going to do this so-called standard addition, what we did is a 1-point standard addition, but you can also have this so-called calibration curve style of standard standards. Okay, so gaya nito, itong sample mo, lahat yan sample. Okay, yung isa wala kang dinagdag na standard, tapos isa 5, 10, 15, 20. And then you're going to dilute them all to whatever is the final volume. And then the way that you're going to do it is you're going to get the signal. Okay, so as you could see here, yung wala kayong dinagdag na standard, yun yung parang corresponding signal niya. And if you're going to plot it, usually, kung ano yung nakuha mo doon sa x-axis dito, yun yung corresponding concentration ng unknown. And I think this was discussed there in the module. Okay? Kasi yung ginawa ko ating calculation, 1 point, ano lang siya yung, we just add known concentration of standard in the sample. But this is the other way of doing it. Pero mas matrabaho lang siya. Okay? Because you're preparing some sort of a calibration curve. Okay? So, mangyayari nito, kung ano yung reading doon sa y-axis mo, okay, yun yung concentration na makukuha, yung corresponding doon. Okay, yung signal na makukuha doon. Now, the last one that I have here, hopefully may time pa tayo dun sa module, is the use of the so-called internal standard. So sometimes, if you want to monitor the analysis that you have, you add an internal standard. So the internal standard mo, hindi pareho doon sa analyte. Okay? The idea tell you about it. Kasi minsan sa pag-run mo, yung reading or yung signal ng analyte mo bumaba. Now the question, bumaba ba siya dahil mababa yung sample mo or konti lang yung volume na na-inject? Now if you have an internal standard, maganda yon. Kasi usually, makikita yung ratio nila. Okay? So, when you do internal standard, you add known amount of a compound that is different from the analyte. And usually, ganito yung formula na meron kayo doon. Okay? The reading from your sample and then equals to F from the reading of the standard, internal standard over the internal standard. So meron kayong tinatawag na F. Diyan. Okay? So this is useful for analyte in which the quantity of your sample analyzed or the instrument response varies slightly. So let's say, minsan mas marami yung volume na nakuha ng injector. So makikita mo na mataas yung analyte. So kapag meron kang internal standard, makikita mo mataas din yung internal standard. So yung ratio ng dalawa magkapareho pa rin. Okay? So yun yung main use ng internal standard. So let's try to solve this one. In a preliminary experiment, a solution containing 0.0837 molar of substance A and 0.6066 molar of internal standard gave peaks areas of 423 added to 10 ml of the unknown, and the mixture was diluted to 25 ml in a volumetric flash. Now the mixture gave the chromatogram for which the RA is equals to 553 and the RIS is 582. So find the concentration of the X in the unknown. So how are we going to analyze this? Okay, so the formula is AX, not AX, no. RA over the concentration of A, and then F, RIS over the concentration of IS. So maybe the first thing that we get here is the F, right? Because meron tayong 423 over 0.0837. Sa kabila naman, F, meron tayong 0.066, oh, not that one, 347 over 0.066. And we have the F here. Ano yung value ng F? Ano yung calculate ko? Anong F? Yan yung tinatawag nating response factor. Ano yung nakuha niyo? Four two three divided by 0.0837 times 0.066 divided by 347. Oh, sorry. I got 0.961. Now we're not that young. We just get the so-called response factor. And what we're going to do is the same thing. We still use the formula, but this time using the new reading. Okay. So if we're going to look at here, so what's the unknown that we have? So we have 10 ml of this IS added to 10 ml of the unknown, and the mixture were diluted 25. So I can put here maybe 553 over A. And this one I have a 0.961 times 582. Now what's the concentration now of your IS? So ano yung concentration ng IS natin? So initially it is what is the initial concentration of our IS? 0.146. And we multiply it with ano yung initial concentration niya? I mean volume. 10 ml divided by ano yung final volume? ml. Na-gets? Nakuha ba yung ano? 10 divided by 25 times 0.146 giving you is it 0.584, 0.0584? So now I can put this one here. So from this, pwede ko nang isolve yung A. What is A? I think the question should be this one should be an A. Find the concentration of A in the unknown. Ano sagot niyo? 8.058. Now, once you get the 0.058 there, oops, you can now solve for the concentration of A. And that would be what? Okay. Nine six one times 582 divided by 0.0584. So I get this on this side. So 553 divided by this. Now the question, is this the final answer? Ito ba yung final answer natin? Remember, this is not our final answer. Why? Because we diluted this. So we have to multiply it with what factor? Ano yung dilution na ginawa natin? So the sample, we have 10 ml that we diluted to 25. So it will be times 25 over 10. You're still familiar with this one? The dilution factor, which is just the reciprocal of dilution. So the final answer would be 0.0577 times 2.5, right? Which will give you around point. Sa tanong, may natutunan ba kayo? Naku, wala na tayong time din sa module. So question. But don't still ignore the module. Okay? Iba lang kasi yung way nung pag-deliver nila doon kaysa doon sa deliver ko dito. And I'm sorry, we're a little bit behind kasi nga this week is Philippine Chemistry Congress, in case you don't know. So I'm a speaker tomorrow and I attended some of the talk, especially by my blackmates. So bago tayo nag-meet, two blackmates of mine or two batchmates of mine, both from UPLB, presented the research. So we still have time right now if you want to. Okay? So, okay na tayo dito.
Yes, sir.
Yung iba, thumbs up na tayo. May natutunan kayo kahit paano. So we will see in the problem set. Okay? Oh, that's not the one. Here. So, ano yung tanong ninyo? Exercise 2. Hopefully masagot ko. Sample 1, sample 1. 3, 2. So, ano yung ano nyo? Question dito. Problem 1, 2, or 3? Number 2. Okay. So, you're asked the minimum distinguishable signal. So, yun lang yung YDL something sa atin yung ginawa natin. So, if we're going to solve it, if we follow here, I think this is the one. No, that's not the one. Here, right? Tama ba tayo ito? Pero doon sa atin na solve, so this is just the Y blank plus 3 times the standard deviation. So maybe we can do the plot on this one. So, iano ko, i-excel ko We have 0, 0.1, 0.5, 1.00, 1.50, 2.0, and then this one is nawawala ako ng signal. So 0, 0.0170, 0.0967, 0.1957, 0.2917, and 0.3953. So I can, get that one because I need to get the slope. Yung ginagawa ko lang dito parang pinaplot ko lang sila. Oh, may nadali ako. So I think that one, that should be 0.0967. Tama ba input ko? 17967, 1957, 2917. So if I'm going to do this thing, I'm going to get the plot trend line, and this is equals to this one with an R squared of 0.999. Okay, so we get now the y or the slope. So the next thing that we're going to get is the blank reading. So input ko lahat, 0.0071, 0.0053, 0.0045, 0.0057, 0.0069, oops, 0.0064, 0.0056, 0.0072, and 0.0060. And then I can do the other. Right? So ano ang gagawin natin? Anong ginawa nyo? So minimum distinguishable signal. So if we have it here, gagamit ako ng whiteboard. So that's SM, SB1, and KSB1. So isusulat ko sa whiteboard. Oops, hindi tama. Mali. Yan. So ano yung nakuha natin dito? SB1, if we're going to look at my 0.06078. Plus, we can set that as a 3, and then you have 0.00905. And what do you get? Ito ba nakuha nyo? Wait, I just want to make sure. Baka that's the case, malito. So 0.006078 plus 3 times 0.00905. Ba't ganun? 0.006078 plus 3 times 0.00. Teka, ilang zero ba yung 9? Medyo mali ata. Ay, tatlong zero. Mali na naman. So I have this one. Kuha nyo yan. So anong problem? Mali yung guide. Baka sila mali.
Nasa answer key po.
Baka sila mali. Because we did everything by the book, right?
Sir, ganun din po yung sa exercise 4. Parang iba po yung decimal place na nakalagay sa answer key sa nako-compute. Sinunod naman po step by step talaga.
Oh, yun na nga. Pero we can also have the benefit of the doubt na baka mali yung guide. Because we did everything by the book. Right? Lahat kayo nakuha ito. Everyone, when you do the thing, ito ba yung nakuha nyo? Yung answer key yung mali. We don't know. Okay? But I'm going to bring it up kung sino man yung gumawa nun. Kasi ginawa ko ito. Ginawa nyo ito. Oh. So we can always have the benefit of the doubt na baka mali yung key. And if we're going to continue, ano yung next na tanong? Malamang mali din yung key, right? So, Shara, ang nakuha mo ba itong nandito o yung sa answer key? Shara, itong 0.0088? Okay. Kasi kung meron mang nakakuha ng sagot pareho sa answer key, let me know. Baka mali ako. Please, if anyone got the answer similar to the answer key, let us know. Maybe meron kang ginawa na mali kami. Okay? But the thing is, if everyone is right, so we can always have the benefit of the doubt na mali yun doon. Okay? Yan ba yung kaya kayo nagtanong, bakit ganito? So question, and kung mali na yung una, malamang mali din yung pangalawang answer key doon. Ano ba yung next na tanong doon? So ano yung LOD? Ano yung LOQ? So malamang ifa-follow natin yan dito sa formula na meron sila. So LOD is just do it on the whiteboard. So LOD is just equals to 3 times the S of the blank over the M. So if we're going to do it, just 3 times 0.000905 divided by ano yung blank na meron doon sa ating slope, 0.1975. And that would be equals to what? Kasi yung LOQ, ganun din. You just multiply 10 times 0.000905 over 0.1975. Right? So you have here 0.01, maybe we could say 14, and the other one is so usually it's 3.3 of 0.14. Right? Or I think we need to wait. Baka ano ba yung ano? Baka mali yung significant figures natin. I just want to double check. Yep. So that's what our answer is. And we are way up, right? So they have 0.0117, 0.0261, and 0.0871. I will ask them about that thing. And I will ask their solution, compare it with our solution. Tanong, tapos yung isa, anong experiment yun? Although it's 1 o'clock. May klase ba kayo by 1 or okay lang sa inyo tuloy tayo? Ano yung tanong nyo sa experiment 5? Nasaan na ba yun? External standard. Mortal scene. Ito 5. Diyan. Ito? Hindi na naman nag-match sa ano? Sa answer key. Yung 1 or yung 2? Pareho. Okay. Hinanga natin. A 1 ml well water is analyzed for free residue using the standard. The water sample is transferred to 50 ml volumetric flask. So 1 ml na nilagay sa 50 ml. And then aliquots of 5 ml are spiked with different volumes of 2 ppm Cl2, after which the solution are diluted to 10. Okay? So we have this. Teka, ano yung tanong sa first? Parang may kulang. Incorporate the oxidation factor conversion. Something is missing in number 1. Right? Tama ba ako? Or naaantok na ako? Kasi try natin i-picture yung problem. Just to be sure. So, magwa-whiteboard ako kasi hindi ako makapagsulat doon. So, sabi doon, basahin ko dito sa aking notes. So, na water, tapos transfer mo to at dinagdag ng 50 ml. So that means your 1 ml was diluted to 50 ml. And then what happened? You put 5 ml here, 5 ml here, 5 ml here. Aliquots of 5 ml are spiked with different volumes of 2 ppm, after which the solution was diluted to 10 ml. Right? Teka. Parang may kulang. Aliquots of 5 ml are spiked with different volumes. Okay. So, and then you add here 5 ppm, 2 ppm chlorine. So you have 1, 2, 3, right? So let's try to get an absorbance here of 0.170, 0.343, 0.513, and 0. How do we put this one here? 2 ppm times 1 over 10. And that is equals to what? 2 times 0.1. So, siguro pwede natin ilagay na 0.2, 0.1, 0.3. Ay, mali. Tama po. So, that's 0.40, that's 0.60. 0.20. So, 2 times 2 divided by 10. That's 0.4. And then 2 times 3 divided by 10, that's 0.6. So, ito yung plot. And then the reading that you have is 0.170, 0.343, 0.513, and 0.768, right? So try natin ano to. Andiyan pa ba kayo?
Yes, sir.
So I'm just trying to show to picture to you kung ano yung problem all about. So kinuha natin yung concentration. So you have 0, 0.2, 0.4, and 0.6. And then we have here 0.170, 0.343, 0.513. Oops. Okay. and 0.768. So let's try to we have. So siguro ang gagawin natin dito is we determine through this yung concentration ng chlorine. Okay? So we're going to what? Get the thing here. So anong gagawin natin ngayon dito? So we get the reading of Y and then determine X. So 0.17 minus 0.1539 divided by 0.982. Ano yan? 0.160 na yan. 0.016. Anyone? So yan yung concentration ng iodine mo, ay chlorine mo doon. So balik tayo dun sa whiteboard. So ito yung amount mo, 0.016. Pero dito lang yan. So anong kailangan natin gawin? Yung right? What do you get? Oh, ppm. Yung ppm din yung bigay nila eh. Ang taas. So maybe I'll try to look at this one. Pero I think this is the concentration of your chlorine in the original sample. By next meeting, pag nag-ano tayo, i-resolve ko to. But I want you to analyze kung tama ba itong ginawa ko. Because we took at the calibration curve there. So meron siyang Y value. So meron tayong Y equals to mx plus b. And all I did is calculate for the x. And once I get the x, this is the value that I get. And I just multiplied the dilution. So meron tayong 5 ml na dinilute sa 10. So that's why it's 10 over 5. And then meron tayong 50 from 1 ml. That's why I multiply it by 50. And this is the one that I come up. Yung meron sila dun, taas. Hello? Now, I want you to solve it. Dito din ba yung number na nakukuha nyo? Sino ba itong siyam na to? Is this the number that you get? Hello? Do you get 1.6 also? Anyone?
Yes po, 1.6 din po, sir.
I mean, yung iba, 1.6 ba yung nakukuha nyo? Kagaya nung problem 2? Lahat tayo consistent, pero yung answer key hindi. Yun din ba yung kaso? Ha? Aside from JPDC? Hana, ano nakukuha mo? Nakuha mo, 15.7 lang nakuha mo. Si Shara, 15.7. Yung iba, so Hana, ano nakuha mo?
Sinundan ko lang po yung ginawa niyo, sir.
1.6 din?
Opo.
So si Shara lang yung naiiba. So we will look at it. So titingnan natin. Okay? We'll see. If the answer key is not right, but I'm going to ask them about it just to be sure. Okay? So I have to go. Tutulog pa ako. So if you have any question, just I would suggest i-shoot nyo na lang doon sa Facebook. And I don't know if you know a person, there's one who wants to join the class. Austria ata ang apelyido. Sino ba yun? Titignan ko. Yeah. Are you familiar with Nelis, Austria? So if he wants to join the class, kung pwede pang mag-reg, still the class is still open. Okay? So I'm going to make the recording, the link sent to you just like the last one, once this is done. So kung wala nang tanong, magandang hapon sa inyong lahat, and we might meet again on Thursday. Okay? So paalam.
Thank you, sir.
Thank you po, sir.
Thank you, sir. Bye po.